I spent my entire weekend trying to organize my hall closet. And honestly, it was just shockingly messy, like pure chaos.
Oh, well, I can only imagine.
Yeah, it was just winter coats tangled with old board games and uh, exactly one lone rollerblade. But sitting there, I started thinking about the universe's ultimate organization system.
Right, because the cosmos is, significantly better at managing its stuff than we are.
Mm-hmm.
I mean, gravity has had a roughly 13.8 billion year head start on your closet organization.
Fair point. So today, we're doing a deep dive into the source material you sent over about the cosmic web.
Yes, and we aren't just looking at where the stars are. We're really looking at the actual information content of the universe's structure.
Which honestly paints this incredibly optimistic, beautifully elegant picture of how the cosmos organizes itself, right?
Absolutely. But to understand how it organizes all that information, we first have to look at how scientists have traditionally measured it. For decades, astronomers, well, they mostly just measured density.
So basically just mapping out how stuff to certain spaces with matter.
Exactly. Which makes intuitive sense. But here's the problem. Density completely misses what physicists call anisotropic deformation.
Wait, anisotropic what? You have to translate that for me.
Right. So think of it this way. When gravity pulls matter together in space, it doesn't just clump it into perfect uniform spheres. It squishes and stretches it in different directions.
Oh, I see. Like into long threads or flat sheets.
Exactly. That stretching and squishing is the anisotropic deformation. And to measure that specific shape, scientists use a math concept called a shear tensor.
Okay, so is measuring just the density of the universe like judging a book solely by its page count and weight rather than actually reading the plot?
That is a perfect analogy. The shear tensor is the actual words and plot. And mathematically, it carries 5 times more information than density alone.
Wait, really? 5 times?
Yeah, so by only looking at density all these years, we've basically been ignoring about 83% of the available information in the cosmic tidal field.
That is wild. We've just been tracking the ink on the page without reading the letters. We've been missing 83% of the data. Speaking of uncovering hidden information, we should probably mention our sponsor.
Oh, right, absolutely.
This podcast is sponsored by Embersilk. Need help with AI training or automation or integration or software development?
Or maybe you're uncovering where agents could make the most impact for your business or personal life.
Exactly. You can check out embersilk.com for your AI needs. So, getting back to the universe's hidden data, where's the cosmic hard drive actually storing all this?
Well, the cosmos is essentially divided into 4 main architectural components. You have empty voids, flat walls, thread-like filaments, and dense clusters.
Right. And in the sources you shared, there's this fascinating mathematical curve showing that information capacity peaks at a mass fraction of about 37%.
Yes, which is incredible. Filaments contain roughly 40% of all cosmic matter, and walls hold about 33%.
Wait, that feels kind of counterintuitive to me. Wouldn't the massive, super dense clusters hold the most information just because they have the most stuff?
You would totally think so.
Yeah.
But if you pack too much matter into one spot, it just becomes a chaotic jumble.
Oh, like putting all my closet items into one giant trash bag. It's full, but it's completely unorganized.
Exactly. Voids are too empty, and clusters are too chaotic. The sweet spot is in the middle. So filaments and walls sit perfectly at the theoretical maximum for carrying information.
The papers also mention that filaments have a low fractal dimension of around 1.8. Does that just mean they're more like thin threads rather than thick 3D blobs?
Spot on. They are vast, thin bridges of matter connecting galaxies across billions of light years. Despite having that low fractal dimension, they act as the ultimate information carriers.
Packing all that disproportionate data into a tiny volume, it's mind-boggling. Has the universe always been wired up like this massive, efficient web?
Actually, no. The early universe was a smooth, nearly uniform soup of particles. It was, well, quite boring from an information standpoint.
So gravity just slowly sculpted that uniformity into this vast geometric order.
Yes. Over billions of years, gravity acted as this incredibly elegant, self-organizing force. And the most inspiring part is that humanity is entering a golden age to finally see it.
Oh, right. The papers highlighted those next-generation surveys being built right now, like DSI, Euclid, and the Rubin Observatory.
Exactly. And the reason those tools are game changers is because they aren't just counting stars to measure density anymore.
They're actually sensitive enough to map the subtle gravitational distortions, that stretching and squishing we talked about.
Yes. They are finally going to read the shape of the cosmos and recover that missing 83% of the data.
That is such an optimistic picture of human discovery.
Hmm.
We're not just staring at the sky, we're literally decoding the universe's ultimate filing system.
It really is a triumph of scientific progress, which, leaves us with a fascinating prospect for the future.
Oh, what's that?
Well, if gravity is constantly working right now to organize the universe into this highly efficient web of information, what unimaginable complex structures will this cosmic network build billions of years from now?
Wow, that is a brilliant thought for you to mull over as you go about your day. If you enjoyed this podcast, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.